Okay, good afternoon, good morning. Welcome everybody to our 207th Reading Online Sports Economics Seminar. I've not put my usual background on, which I will do in the process of introducing the talk. Thank you for joining us. We are obviously hosted by the University of Reading, and we are also sponsored by the Sports Economics Review, relatively recent journal in the area of sports economics, but as of very recently, it is now listed on Scopus, and you'll see it appearing on your journal lists in your countries, I would expect, in due course. A great outlet for a manuscript in sports economics. This week, it is a great pleasure to have Manuel Arrigo, who's presenting "You'd Better Not Overpraise Your Team, Field Evidence on the Effects of Feedback Merit and Luck from Elite Soccer." One thing I'll say before we get going, well, a couple of admin things. One is you'll have seen in the reminder notification sent around that I've put in there the full schedule through to Christmas, and we're even filling up sessions beyond Christmas now, which is great. I also tend to put in conferences in the session in the schedule as well. And so if you have a conference that you're organizing between now and Christmas or after Christmas, please do let me know. I'm very happy and very keen to put it in with any kinds of submission deadlines that you may have. So please do let me know. You'll see that October 5th to 8th is the Play the Game conference in Finland, organised by Rasmus Storm and others, and that looks like an excellent conference if you're able to make it. And as I've mentioned before, we're organising a conference at Oldham Athletic on the, it says in the reminder, the 9th of December. It will actually be the 10th of December, but we're encouraging folk to come for the 9th because there's a game, League Two football match between Oldham Athletic and Walsall that evening, and then we'll have a full day conference the following day with folk both within academia, working in the area of football and football analytics, and also we'll have lots of folk from working in the industry as well. So it was we had a great conference early this year where we had many folk from industry and from academia meeting together. And that was a really interesting event. And so there's another one on December the 9th and 10th. So do look out for that. We'll put out some publicity in the next few days. Manuel is happy to take questions as he goes along. So please do that. Manuel, you might not be able to see when the hands go up. So if that's the case, what I will do is I'll interrupt you and then folk can ask their questions even. We've got until 4 p.m. UK time, or I guess 5 p.m. For yourself. If you can take as much as that as you like, and the floor is yours.
Thank you, James. Thank you for having me here and for this introduction. I will start, and also, of course, good morning, everyone. So we'll start sharing my slides. Perfect. Do you see that?
Yep.
Okay. Yes, and I also quickly introduce myself, since I assume not many of you know me. And so my name is Manuel Arrigo, and I started 7 months ago my PhD in sport economics at the University of Lausanne. My supervisor is Marcus Lang. And so today I will present my first working paper, so the paper that I hope in the future will be the first block of my thesis. And I'm very grateful that you are here listening to me, and I look forward for your feedback at the end. And yeah, the topic of today is feedback. I don't think I have to convince you about the importance of feedback, since you all work in university or academia. And so very often you have to give feedback to other colleagues or to students, and also to receive feedback for your works. And maybe sometimes in the past you also felt that some feedback wasn't maybe rewarding enough your work, so maybe wasn't fair. And this paper that I wrote with my two colleagues, Carlos Gomez Gonzalez and Marcus Lang, analyzes actually this situation. And so let me introduce you the topic with an example, not from football, so a general example. So let's say there is a singer that she sings a song, and we could rate, so evaluate her true performance from 1 to 10. And let's say the performance is a 7. And then there is an external judge that has to evaluate this performance. And he says, okay, this performance is actually an 8 out of 10. So how come? But simply because it's difficult to assess a performance. So there could be some personal judgment, there could be some social or cognitive bias. Also, when we base our performance appraisal on some outcomes, this outcome could be influenced by luck or some noise. So it's very possible that exactly the same performance could be rated as a 6 from another judge or from the same judge maybe another day. So in performance evaluation, there is this variability, this noise. And I would call this noise throughout the presentation as outcome discrepancy. So the discrepancy between the feedback, so the outcome, and the true performance. And there is a lot of literature that concentrate on how feedback influence the subsequent performance. So if we receive a positive feedback, how we will perform next. So in this example, how the singer will write, how good she will write the next song or sing the next songs. And there is a lot of literature, however, also a lot of contrasting results about feedback. And in this presentation, I will also try to convince you that also this outcome discrepancy measure could influence the subsequent performance, because the singer could perceive that she has been over-rewarded or under-rewarded by the judge appraisal. And maybe she felt that she experienced some luck or bad luck. And literature on reaction to luck over or under rewarding is very rare because it's difficult to measure true performance in the field. Also, this feedback sometimes is difficult to gauge. And of course, this random variation within the two evaluation. But with football or sports in general, we can do that more easily because we have a lot of data, and so we can use sports as a laboratory to answer this question. So concretely, we proceeded in this way. So as a performance, we use the expected goal as measure of true performance. We use the expected goal score. Why? So maybe I think you are familiar with the expected goal metric and the name, but to clarify things, it's simply a measure that based on shots, so in shots characteristic like distance and angle to the goal, try to calculate how much goal a team is expected to score. And so we can also build up the difference between expected goal of team A versus expected goal of team B to build kind of a fair result, or a true performance results. And why I say true performance? Because there are some previous research, particularly this paper of Brescia and Flap of 2020, that showed that expected goals were best able to predict future performance compared to simply the actual score. So this will be our measure of true performance. As a feedback, we will take winning or losing at halftime, because of course the actual result is very prominent, and so people will look at players in the field will orient their behavior based on the true score. And so we will see, so we'll use halftime as a feedback measure to see how this influences subsequent performance, namely performance in the second half. And as an outcome, yes, I believe there is a question, so please go ahead.
Yeah, so I'm an economist, so obviously I agree that the expected goals is a very good measure of the true performance. But if I was talking to my friends in the pub and I had to try to explain that XG is a better measure of the true performance than the actual result, they won't believe me. So we hear this all the time on the telly, that the commentators are mocking the XG scores for being so not reflective of the true performance. So I don't know, are you able to say a little bit more about how you're sure that the guys in those paper got it right, and that the XG really is the true performance?
Mm-hmm. Yeah, so thank you for the comment. I also had the same conversation with my friends last week, so I'm like familiar with what you're saying. So first thing to say is that of course the expected goal are a good measure, but probably in the future there will be even better measure of performance. So in this moment, I think this is the best measure of true performance, but of course can be improved. So this is to answer to your true performance. And yeah, what the authors did, they took a combination of past games to predict a combination of future games. And they used one model using just the actual score, and one model they used the XG score of past game. And they did this for a lot of combination of past games and future games, like three past game to predict 3 future games and so on. And they saw that for every combination of past game and future games, the XG model was a better predictor. So the R squared, so the explained variance, was actually higher. So we can conclude that if they predict future game better, they also reflected better what was the performance in the field. So this was the conclusion of the authors, and the paper is based on this assumption. I don't know if it satisfies your...
Sounds good. Sounds good to me, at least.
Okay, good. Okay, so I was saying like outcome discrepancy is built like subtracting the actual score to the XG scores. So to give you an example of the semi-final of Champions League of last year, Arsenal against PSG, the scores after the first half was 1-0 for the PSG. But if we looked at the expected goal, we see a different picture. So we see the Arsenal should have scored 1.22 goals and conceded 0.31 goals. So it should have, on average, be on advantage by almost 1 goal. And if we subtract these two measures, we see that the outcome discrepancy, maybe I will call it also OD for simplicity, was 2 more goals towards Arsenal. So Arsenal was unlucky or under-rewarded by 2 goals compared to the true performance, whereas PSG was scores 2 goals, or was in the result 2 goals better than the expected goal suggested. I think maybe there is another questions from the audience.
Yes, a very short question. These expected goals from the first half are calculated using only shots from the first half in whatever number of games you did this calculation. Normally what you see on TV, expected goals of the first half, they are using all the data set from all the entire game. So I'm just curious if you're using just the first half shots of each game. But
yes, exactly. Only the first half shots. And the data come from Opta. So I didn't calculate the expected goals myself, but yeah, I've taken this measure.
But then Opta, I think, I'm not 100% sure. I think that this expected goal from the first half is using all the data set. That's what I understand.
I mean, they have a machine learning system to how to say, to rank different measures, like distance to the goal is calculated in this way, like for calculating expected goal score is using I don't know, like it's multiplying by 3 or something like this. But of course, like this metric of expected goal is based on the shot that actually happened in the first half. But to build the model, of course, the model is trained with millions of past data and past match. Is it clear? Is that what you mean, or?
Yeah, well, thank you. Yes, go on. But I think there's an issue there. May be an issue. Thank you.
Okay.
Manuel, I think the question is, if I understood it correctly, whether the database that you just described with the millions of millions, whether this is based on overall matches or on half matches.
Okay. No, okay. So I think it's built on all the matches, not only, it's not trained with only first half data, but with full match data. Yes. Thank you. Okay, so I will go on with the presentation. So this is our calculation of outcome discrepancy. And maybe also some of you could think, okay, maybe this difference between actual score and XG score isn't a measure of luck, but it's just the team ability. So to analyze that, we regress the outcome discrepancy to some team characteristic or match characteristic like win probability derived from betting odds, market value, home advantage, and team quality measures. And we see that adjusted R-square was less than 0.5%. So we see that this difference between actual score and expected goal score is largely independent. And also, if we try to regress the second half outcome discrepancy with the first half outcome discrepancy, OD, we see that there is no significant correlation. So this OD is not also influenced by in-match dynamics, but is like independent between halves. And you probably noticed that win probability is a significant predictor, even though the variance displayed is very, very little. And this is probably the case because, like in the long run, better team also have better capacity of finishing, so they can convert slightly their scoring chances better than average team. So we see that actually this portion is very, very little, but still there is this effect. So in our regression, we will also include all these factors that you see here to kind of isolate the portion of OD that is truly random. And so we'll come to the hypothesis to see how this OD can influence team second half performance. And in social psychology, there is this very prominent bias, which is self-attribution bias, that posits that when people encounter some successes, like for instance, I win a race, I will say, yes, I was truly the best, so it's all my ability. And when I arrive second, so when people encounter some setbacks and failures, they tend to attribute that to external causes. They will say, yeah, but it was training, so the weather wasn't good enough, or I was very unlucky, and so on. So what we actually see is that sometimes people, when they are successful, they underestimate the role that external circumstances played in their successes, and they are overconfident about their own ability. And this will lead them to make poor decisions. We see that, for instance, there is a research with CEOs that see that when they are overconfident, they tend to overinvest, and then they take poorer investment decisions afterwards. And also in sports, there have been some previous studies that wanted to quantify luck with these external circumstances, like this very prominent paper of Garriott and Page that compared shots that hit a post and then went in with shots that hit a post and didn't result to a goal. And they say, okay, the underlying true performance of these two shots, of these two players, is the same, but actually managers committed some outcome bias because they evaluated the performance of this player more. Here, the basic idea is the same, but instead of looking at performance evaluation, we see how or if this luck or bad luck can influence the subsequent performance of players themselves. So if also players are overconfident. And the hypothesis is this is the case, so positive discrepancy, so a result that is better than the XG scores will deteriorate subsequent performance. And if you follow this self-attribution bias, we could also hypothesize that players that encounter bad luck, they will they will not take responsibility of their failure, but they will dismiss the feedback message and lose the opportunity to learn. And this will end up with the deterioration of subsequent performance. I finished with the hypothesis, then I see there is a question. So alternatively, we can also say that under-rewarded players or teams, they could also frame the situation as a loss, as a relative loss, because they can say, oh, well, we deserve it to be an advantage. We had a lot of scoring chances, but we are actually losing. So compared to the reference point of what they should deserve, in their opinion, they are performing less, so they feel a loss aversion, and they will increase efforts. So for negative OD, we had these two alternative hypotheses. So yes, there is a question, I think, from the audience.
Yeah, so how do you differentiate this from just regression to the mean?
I will explain this later. So I have a robustness check later, so I will postpone your question if it's okay.
Yep.
Okay, thank you. Then we have also some hypotheses about the feedback valence, so about how halftime state will influence the second half performance. And as I said in the beginning, the literature about this is controversial, but there is this nice theory or framework of Kluger and Denisi that explain how positive feedback and negative feedback can actually impact performance. And they say very different things can happen, like in the case of positive feedback. So when people receive feedback like, oh, good job, you did well, it's possible that people allocate energy to other goals because we all have multiple goals that we pursue at the same times. So maybe if we are doing good in an area, we decrease our effort on this area to try to achieve also another goal. But it's also possible that we are motivating by the feedback because we are doing good, so we increase performance. And in football, we say, okay, so if a team is winning at half time, it's not maybe so optimal if they try to play even better because they want to win the championship, right? Not just the game, and so the winning margin is irrelevant. So maybe towards the end of the game, they want to also avoid injuries or save energy. So we believe that, we hypothesize that positive feedback deteriorates subsequent performance. About negative feedback, if someone says, okay, so your work is really bad, we could be discouraged and decrease our performance and motivation, or we could take this as a learning effect and actually improve. And at halftime, team have the possibility to reorganize and to change tactics. And so we hypothesize that negative feedback actually lead to improvement in performance. To analyze this, we collected data from the, yes?
Yeah, I'm sorry, if you mind going back to the assumptions. I mean, is there any kind of evidence here that, and how you reach these assumptions, or can you convince us that these are true? Because I actually have kind of a hard time getting there. That I would expect these to be true, or that these hypotheses are true.
I mean, this is the general theory, and of course there is some difference between the contexts. So starting from the theory, we had to derive some, so to decide what was the case, like if it more this the case or more this the case. So yes, you can see, you can also conclude that this is a little bit speculative.
Because
yeah,
I mean, winning margin, right, is not irrelevant. I mean, I don't understand football so much coming from the US, but I mean, don't they have goals for, goals against? Isn't this quite actually important?
Depending on the league, but in the criteria, so if two teams arrive at the same points, like for instance, in Italy, if two teams arrive at the same, so first place, same points, they actually play another game to decide who is the winner. And so this is a new rule introduced 2 years ago. And before that, they first of all looked at direct matches to see what was the best team. So yeah, winning margin can be relevant, but I will say in a match, so it's very rare situation where you finish at the same points, and so this winning margin will really play a role because the championship is very long. So yeah, win margin is relevant kind of way, but it's very in the hierarchy of things that you have to control. So especially in the football nowadays, where you have a lot of matches to play, I think this saving energy and avoiding injuries could be like more prevalent in the mind of player. But of course, you can argument also in the other way.
Yeah, okay.
And to analyze this, so we collected data from the top 5 European leagues with the 3 most recent seasons. We didn't go back more in times because we needed data from for expected goals separated for the first time, first half and second half. And this is difficult to find online, so we found it available only for the most recent seasons. Then we had to find a measure of performance in the second half. And one measure that we used is the XG score just for the second half, because it's a good measure of overall performance. However, it has also a contra side, because XG score is also influenced by the behavior of the opponents. So we also used pass accuracy because it's more independent compared to the other teams. And the problem with pass accuracy is that maybe a team has a better pass accuracy simply because he plays shorter passes that are less risky. And so they actually performance increase, but it's not real performance. So we also use a third measure, namely long ball accuracy. They also account for balls or passes that are over 30 meters long, so they are more comparable within each other. And since are more rarer, this measure is also more sensitive to random variation. So we use all 3 measures to get a more complete picture. Then as in the, yes, Daniele.
Yeah, sorry. So I think that, you know, all 3 measures are in part influenced by the opponent. So a team that is trailing may press harder, try, you know, put more effort in trying to disrupt your passes, may force you to make different combinations of passes. I was wondering whether you could, you know, I don't know if there's enough data, but if you just focus on, say, pass accuracy from set pieces, right? So that would be an example where, you know, there's that only so much that the opponent can really do to say, you know, to affect how precise your corner kick is going to be, something like that. You know, just I mean, I think that the other 2 measures, you know, pass accuracy and long ball accuracy, are also, you know, subject to the to the concern that they're influenced by the opponent as well.
Yeah, I see your point, and it's true. Like, I think in football, every metrics could also be influenced a little bit by the opponent. And also, you say passes from set pieces, but maybe also a team maybe in set pieces use a defensive man-to-man. So probably is also try to get every ball, and so we can never be sure that. So I think this is a limitation of using data in football. So you always have an opponent. But so the thinking behind this was that this is more independent than actual XG. And then we have so control variable to partially to make this measure more independent. So we'll explain this in 30 seconds. But of course, yes, your concern is a limitation that in the paper we will write. As independent variables, we use halftime state and also this outcome discrepancy. And we divided this outcome discrepancy in 5 categories. First, because the interpretation will be simpler. And second, because probably players during the match, they don't know exactly their XG measure, XG scores, but they kind of have an intuition of it, because maybe they know, oh, we had the 3 big scoring chances, we consider only a scoring chance, so we should be in advantage or something like that. I think also fans, when watching games, the TV, they also have an intuition of if their team was lucky or unlucky. So we approximate this OD to the to the nearest whole number. So neutral OD is when the game is kind of fair, positive or negative OD, and the result is, so to speak, biased by 1 goal, and very negative and very positive when the result is biased by 2 goals. As a robustness check, we also used the continuous variable. So we'll also show that later, but this will be like our main specification. And then as a control variable, we use, first of all, these 2 matrix. They can also like allow us to defend a little bit more the independence of passing, because we had also the season pass or long ball, depending to the dependent variable accuracy for the team, and also the defensive season pass accuracy. So let me clarify with an example. So let's say we are again interested in the match Arsenal against PSG. We want to see the reaction of Arsenal. First of all, we control for the Arsenal average passing behavior, because maybe there is some teams that play safer passes or riskier passes. But also we control for the average pass accuracy that all the other team have recorded against PSG in one season. So we kind of account that if a team is more pressing, so try to press more the opponent, or maybe is more defensive, so leaving more freedom. And of course, this doesn't make 100% with passing accuracy an independent variable from the opponent, but it's an additional control. And of course, we had the win probability derived from betting odds, market value from transfer market, the halftime goal difference, and a home away dummy, and measure of red cards. So this will be like our main model specification with the 4 dummy and neutral OD as a reference category, and also the 2 dummies for the halftime state. And so let's come to the results finally. And first of all, we used a specification without the halftime dummies, so just the OD dummies. And we see that in this specification, in general, teams that are under-rewarded or unlucky, they tend to be better in the second half. Instead, teams that were lucky, they perform a little bit worse in the second half. And this is consistent with the overconfidence hypothesis that we explained before. Then we also added these 2 dummy, winning at halftime and losing at halftime. Here we get a similar picture. So teams that are winning at halftime, they tend to slack off a little bit in the second half. So probably, as I was trying to motivate before, they try to allocate energy, effort or concentration to other matches or to avoid injuries. Where teams that are losing at halftime, they improve their behavior in the second half. And of course, as I explained, we control for team quality, like betting odds. That also should include information about injuries, about mental, physical state of a team, upcoming matches, because of course, betting provider have the incentive to provide the best odds. And also additional confounder like red cards. And when including this dummy, we can see that the general tendency of negative OD, so on the rewarded team, to improve, and the general tendency of over-rewarded teams to perform a little bit worse in the second half stays, even though like for XG scores, the result is very clear, so we can support the hypothesis. Here we see that the picture is a little bit difference, so the effect size is much smaller. Still, we can find some significant result. And I will anticipate that this is also kind of explained partially by heterogeneity in some teams. And so, but maybe some of you wonder why the picture is so different when we had these two variables. Well, because we see that outcome discrepancy and half-time state, they are not independent. And so the correlation is very high. The Pearson error is 0.76. And this also makes sense, right? Because this team is lucky, so he has just one scoring chance and he can score a goal. And he conceded maybe 3 big chances, but one time the opponent team hit the post, one time the goalkeeper makes a miraculous saves and something like that. It's also more probable that, more likely that they will win at half time. And so if we are interested in the whole effect of this outcome discrepancy, we should not control for half-time state because this is kind of a bad variable. However, like controlling for this has also some advantages because the relation between half-time state and second half performance could also be prompted by tactical adaptation. As I said, maybe a team is winning, so it defends a little bit more, leaving some more freedom for the opponent to pass the ball, so the accuracy will be higher. But then if we control also for half-time state, we see that there is still an effect. This is very unlikely that is prompted by or driven by tactical adaptation. So we can see that this effect is really something psychological that has to do with how players think. Yes, there is a question.
Yeah, so one comment is that it would be really useful to show this table side by side with the table in the previous slide. I already forgot what the results looked like in the previous slide. You could maybe you just like flip back and forth, so to see like the comparison of what happens when you do or do not control for. Yeah. So the other question is, could you remind us how the XG measure that you're using here takes into account defensive positioning? Because I know that in the XG community there was Stats Bomb a few years ago, and I don't remember exactly the timing. They said, well, we're going to introduce this much improved measure of FG that does a much better job of looking where defenders are, because 2 shots from the same position would have a very different XG depending on whether you have 3 defenders trying to block the shot or nobody in front of goal.
Yeah, so I don't know exactly the algorithm of Opta, but what they say in their website is that they use over 20 variables, and key factors are distance and angle to the goal, the goalkeeper position, the presence of defenders, and they say like pressure and visibility, the type of shot, so if it was an header, a volley, or one-on-one, the pattern of play, so if it was a set piece or an open play, and the nature of the assist, so if it was a cross or through ball. So defensive, I think they account for the visibility, so how many defenders are between the striker and the goalkeeper, and also the position of the goalkeeper.
Okay, and as far as this this was done throughout the whole sample period?
Yes.
Okay.
Yeah, thank you for the question. And also for the maybe for the coefficient, we can look at the XG. So we see that for negative is like more than 0.10, so between 0.13 and 19, and for positive also the same. And here is a little bit less, so it's less than 0.10. I mean, for some of the variable, like very positive, this is very big. And so, but I think passes change more, like before, like for accurate long balls, we have also a value of 6% of accurate long balls and all the value over 2%. Whereas here we, so the effect is very small. There is only very negative data is near to 2% increase of accurate long ball. Then, as I anticipated before, we also use a spline specification. So we just divided positive and negative OD, and we also included their squared variable. And here we can see very nicely with using expected goal score of the second half, the dependent variable, we can see that unlucky team perform better than over-rewarded team. And there is some kind of evidence of non-linearity at the end of the spectrum, like the conclusion in the central area, so where 90% of the data are situated, is virtually the same. And we also did a placebo test to see if our specification wasn't missing some variable. So we tried to predict using second half outcome discrepancy to predict first half performance. And of course, we should not find anything significant since this happened later in time. And so we found no effect on XG score, pass accuracy, and long ball accuracy. So there is no sign of omitted confounding, and also no sign of regression to the mean. Let me try to explain this a little bit more. So some of you, also before in the question, maybe were concerned that positive OD is actually driven by a overperformance of a team. So if a team is actually overperforming in the first half, and then we observe a reduction of performance, maybe just a statistical rebound of regression to the mean. But then this would also implies that also second half performance, so a second half positive OD is kind of correlated with an overperformance, and so we should find exactly the same trend negatively correlated with the first half performance. So this is not the case, so we try to show with this test that the regression to the mean probably doesn't explain the results. And then we also, we are approaching to the end of this presentation, but actually in the hypothesis, we also had some hypotheses about moderating effect using team characteristics that I present just now for the sake of clarity. So we expected that positive OD is influenced by analytical skills of a team or relative abilities of a team. And then negative OD is moderated by team experience and performance expectation. Let me explain how we think that, starting maybe with analytical skills. So we say, okay, the possible mechanism explaining why positive OD makes second half performance deteriorate is that because there is this overconfidence bias. And so we say, okay, teams that can better recognize that they are overconfident, they probably can mitigate this bias and show a weaker reduction of performance afterwards. So it's difficult to find the proxy for analytical skills of a team. We came up with this goal scorer from set pieces, because set pieces often imply some scheme and tactics that are programmed before the match. And so there is normally teams that can score a lot of set pieces, have a good staff that can spot the weakness of the opponent and try to valorize the strength of a team. So we know that this isn't a perfect measure of analytical skills, but kind of goes in this direction. And then there is also this bias, this Dunning-Kruger paradox, that show that overconfident individuals are not the one with the most ability, but they're actually weaker teams or weaker individuals that are less ability. They kind of get overconfident more quickly. So we expect a team with lower win probability at the beginning of the match to show this overconfidence more. Then we had the two hypotheses with negative OD, and we say, okay, experience is a factor that also helps individual to cope with discomfort situation. Like if I'm experiencing bad luck, but I have a lot of experience with this kind of situation, I can probably frame this as a motivation to regain what I deserve. And maybe some younger team cannot do that, so they're more easily discouraged. And then, since the possible mechanism here was loss framing, loss aversion, we expected, okay, maybe higher performance expectation, so teams that are the favorite before a match and then they are in a difficult situation, they feel kind of more the pressure to perform and they feel this loss framing, loss situation in stronger terms. Let's see what the result says, and you can see the effect of positive outcome discrepancy divided for teams with high analytical skills and for teams with low analytical skills. We can see that teams with high analytical skills actually do not show an overconfident behavior, so they do not show a reduction of performance afterwards, whereas weaker team, they do. And the interaction, so we can only support this hypothesis actually just for accurate passes, because the moderation is significant only in this case. Then we have team with relative abilities. We can say we can see almost the same thing again, significant just for accurate passes. We see that consistent with this paradox, teams with lower ability actually are overconfident, whereas teams with higher ability, they do not show this overconfidence bias. Okay, so what about the performance improvement after negative OD? The hypothesis was that team age, so team experience, also plays a role. We see that, again, just significant for the accurate passes, that younger teams, that older teams actually can make the most of this situation, like when they experience negative external situation, bad luck, they can perform better, whereas younger teams, they do not show this increase in performance. Yes?
Sorry, what is this? What is this testing? What mechanism? This is testing loss aversion?
No, this was more like the idea that experienced team when they experience a team when they facing bad luck, they can frame this as a positive situation, whereas younger teams, when they are very young, so they can get discouraged more often. So this is not really loss framing here.
Okay. Okay. I mean, all right. Thanks.
And here we are actually testing loss framing with success expectation. So we expected favorite team to be more loss averse. And we actually we can actually observe the contrary. So teams that are underdogs before the match, when they are facing bad luck, they increase performance, whereas experienced team do not, and actually they reduce performance. So this was contrary to our expectation, and we came up with an orthodox explanation for that. So maybe favorite team, when they experience bad luck, they maybe simply say, okay, so we were the strongest team. We had a lot of scoring chances, but today the ball doesn't want to go into the goal. So they maybe become discouraged, or actually what we see here is that they could possibly become overly frenetic, right? Because they maybe try to get quicker to the ball, so their passing accuracy actually decrease. So this is a dox explanation that we couldn't predict with theory. So yeah, that was kind of my presentation. So let me wrap up the most important points. So we found that team, when experiencing a positive of this or good luck, they could be overconfident and decrease performance. So previous studies show that NFL coaches, soccer managers, soccer decision maker can sometimes be overconfident and take less optimal performance evaluation and decisions. Here we contributed to the literature showing that players too can be fooled by randomness and decrease subsequent performance, so that also player can be overconfident. Then we also show that teams that experience negative ODs or bad luck tend to increase concentration or qualities of performance in general, possibly because of this loss aversion. Then we believe that these results are actually also important for managers, and so they bear some interesting practical implications. Because of course, managers and principals in firms or organizations cannot control luck, and also will be not ethical for them to manipulate their feedback message just to increase the performance of their team. But still, they can decide, and especially for intermediate feedback, so feedback that do not happen at the end of the project, but just like a half project. So probably the manager give a feedback for the employee, and he can decide how critical the type can be. So he can decide to be very severe, to watch every single detail and point out all the things that can be improved, or can decide to be vague or unspecific because it's just the intermediate feedback. And sometimes also, since we come back to the beginning, so it's difficult to assess performance. Maybe it's undecided between the two grades, like in the university. And so the result of this study showed that a good practice could be like for intermediate feedback to provide them with critical eye and attention to details. And when decided, try to opt for a lower evaluation. Why? Because in this way, you kind of avoid that your performance, your feedback is overpraising the team, and so you don't incur the risk that the team becomes overconfident. And since this is just an interim feedback, in the final evaluation, you can still do a fair recognition. So if you feel that in the intermediate feedback you are too severe, you can still, in the final evaluation, accordingly reward your team. And of course, this paper also has some limitation, and the first one could be generalizability, because the subject, this paper were experienced and a successful footballer, so maybe in a firm people can behave differently. But of course, since they are very successful, so they are top athletes in the field, it's also possible that this bias also show a lower bound for the overconfidence effect. Then another limitation is that we also use half time as a feedback moment, but in reality, of course, if just after the pause, a team score a goal or is very lucky or unluckily, there is a penalty kick. So the team that is lucky or unlucky can change multiple times and shift continuously. And lastly, and we already pointed out this during the presentation, of course, we could observe just team level reaction and not individual psychological response of individuals. Very often in organization projects require collaboration between multiple individuals or are led by teams. So this is unuseful, but we could not, of course, say implication about there will be probably some heterogeneity also in players' characteristics that we could not analyze. And of course, the dependent variable were also partly influenced by the opponent's behavior. So thank you for listening, and look forward to your other comments, feedback, question, and whatever you want. Yes, Dennis.
Great, thanks very much, Manuel. And Dennis, go ahead with your very keen question.
So from almost the beginning, Manuel, my feeling was that what you're going to demonstrate to us is that XG is a bad measure of predicting the quality of a match. And at the end, that's what I think you've done. So the first regression you showed us was that XG, the observed deviation, has a very low R squared in that regression, but you had two statistically significant variables. In other words, whatever XG is doing, there is systematic information omitted from the predictor of what goals are going to be, which means it's a bad measure. It's not an expected goals measure, it's something else. And then what we saw was regression after regression with changes like, oh, let's consider experience and so on. And those things tend to show significance, which just means they were omitted from predicting what the expected goal should be. So convince me that that's not what you've done, and convince me that the real feedback, and this is my other fundamental problem with what you've done here, is feedback is when a coach grabs you by your jersey and says, I told you to stay on the right and you went to the middle. It's not, oh, at halftime we're behind and we thought we were going to be ahead, right? I mean, feedback is being coached up. So explain to me, or just ignore my rant, one of the two.
So actually, in the first table, the dependent variable was not XG, was outcome discrepancy, which is the result minus the XG. So here I want to demonstrate
in other words, the regression error has statistically significant predictors.
Yes, and I account this in the regression. So 95% of OD is random, and then there is some significant factors, and I use them as control variables. So I can neutralize the effect that is predicted by winning probability. And so the rest, the variance that is not explained by win probability is actually random. It can be used as a measure of over-rewarding and under-rewarding. And this has a psychological effect. I'm not demonstrating that expected goal is a bad measure. Expected goal is a highly significant measure of results. It's just the difference between the scores. So like in the study of Garriott and Page, when they compare shots that hit the post and result into a goal, and shots that hit the post and went out, they're doing kind of the same thing. So they're comparing shots that have the same XG. So they don't say this, but they show that this shot come to the same distance from the goal and so on. So similar shots, similar XG, but one goes to a goal, so positive outcome discrepancy, and the other goes out, negative outcome discrepancy. And they say this is luck. So if a ball after hitting the post enters the goal or not, it's just random. And they say the same thing, but more quantitative. So just instead of using this quasi-experimental design, comparing these two types of shots, I take the general tendency. And about your second comment about feedback, of course, during a match, players have a lot of feedback, and also a trainer scolding a player saying, okay, you're doing bad, and so on. This is also a feedback, of course, but we receive multiple feedback. And of course, also, I mean, I think it's a fair assumption to say that if a team is winning, the team believes that it's doing right, is doing a good thing. And this also corresponds to the definition of feedback. So I will say this is also a different type of feedback, less, more outcome-based, less specific, but still a feedback.
Okay, thanks, Dennis. And then next we've got Kenneth.
Yeah, I guess to that last point first, right? You don't know. So, like, unfortunately, we can't see what's going on at halftime or what the coach is saying. So unless there's information, I think this is quite a strong assumption to make in terms of feedback, because you talk a lot about loss aversion, but this is all dependent on some sort of reference point, right? And it's not quite clear what exactly is the reference point. Of course, you have pre-match odds, but then which is forward-looking, but then you have XG, or maybe not XG, this OD, which is backward-looking, and then there's kind of no reconciliation of the two. But the main question is, have you seen this Klein-Tesselink paper?
Yes, I've seen this.
Because my prior coming in then would be actually, one, that there's no effect, and two, if there were an effect, it would be quite small. And so I think from what I see from your regression tables actually is the coefficient coefficients are quite large. So why is my prior wrong here?
Yeah. Okay, so one thing is that in football, so part of the results of winning and losing at time are also driven by tactical explanation. Like if a team defend more, of course the opponent will pass the ball more freely. But of course there will be, like in Innsbruck, Flap and colleagues presented another paper to answer to the paper of Tesselink, and they show that actually if you just look at games where the betting odds are kind of tight, so where there is no clear favorite, we actually see this loss aversion. So what Tesselink and colleagues may have overlooked, and also the previous paper of Berger and Pope may have overlooked about loss aversion, is really to include these betting odds in their consideration. And so they included some match where there was a clear favorite, and of course the clear favorite, even with just above of 1 point, like in basketball, they will probably still be loss averse, because they say, oh, we are so better than the opponent, but we are actually performing almost the same. So they could be loss averse anyway. So yeah.
Okay. And sorry, one last thing real quick is why not coach fixed effects?
So coach fixed effect will be almost the same to club fixed effect. So in this case,
I don't think so.
Yeah, I disagree on that as well.
I mean, in just 3 seasons, there will be not so many changes in. I mean, okay, well,
so it's not necessarily the changes too, right? This way you talk about strategy and stuff. I mean, and league. You have league fixed effects, but I have to credit Steven Szymanski here, who I think is in the chat, from football, from his football economics book. But I think some of this strategy stuff with like long balls and all of this stuff, it can help with that. But just generally tactics wise, this is largely coach driven, I believe.
And motivational as well, just to chip
Right.
in. So some coaches will be more motivational in the dressing room than others if the side is losing at halftime unexpectedly, say.
Okay, yes, I can try to include also this coach fixed effect. Thank you.
Thanks, Kenneth. And then next is Georgi.
Hi, Manuel. Good to see you again. So I'm going to drop in the chat as well. I mean, I know you know this is a resource, but to your earlier point that perhaps the data on halftime scores does not go as far, goes as far as at least 0405. Obviously, you're not going to have FODMAP data for that far, but OddsPortal lists halftime scores for virtually every game. So that may help you increase your sample. And then my next point was going to be, so like echoing Dennis's point and Kenneth's point, is that, the reference point. Football is, unfortunately, you cannot take a timeout. So for instance, that has been tested in other sports. Does halftime necessarily where, you go into the locker room, represent a reference point, or like Dennis mentioned, like just grabbing a player and then I would even go as far as to say not just coach fixed effects, but coach interacted with situation in the season, or like season-long objective sort of fixed effects, because different coaches may react and you may pick this up qualitatively from their post-match interviews. Like, for instance, you see the XG for the game is like 3, but then they only scored 1 goal, and the coach will then say something in the conference of, resembling, oh, we had so many chances, but so and so. And perhaps a more interesting question, sort of tangential to your research, is do the coaches then sub out players that do not realize those moments? For instance, if you have accumulative XG per player statistic, and if a player accumulates a lot but still has no goals to score for it, do those players get subbed and whatnot? But obviously echoing previous comments, there isn't sort of this universal measure of how coaches would react to a lot of XG accumulation. Like, for instance, at halftime, they could say, oh, we're doing well, like, you just keep playing, like the goals are going to come, like you're that close. Or maybe the coaches are ripping the locker room apart and, throwing the boards left and right and saying, how can you not score from these positions? And so on and so forth. So maybe there's a proxy to measure, like, are coaches less or more patient depending on the situation where they are in this season, how much the game matters. But just echoing on previous comments.
Yeah, thank you for your comment and also for the resource you posted in the chat. I will have a look. Yeah, when we were reflecting on the paper, we thought, okay, so the reaction will be more driven by players and how they react, because it's human psychology. So we didn't talk about so much about training reaction, because this, of course, can have a big influence about how team reorganize, like if it's winning or losing. Like, for instance, in the specification where we have the 2 dummies for halftime win and halftime losing, if we control for that, so we exclude tactical explanation, basically, and we still find an effect. And personally, I believe this effect is more driven by the team, not so much by the coach, because it's how the team in the field react about being over-rewarded, like having experienced some good luck or bad luck, instead of what the trainer tells you to do. But of course, like, these are just assumptions. I mean, I can explain this in that way, and some of you can say, no, the trainer is has a lot of influence also in every situation. But yeah, I will try to kind of add some coach fixed effect and something like that.
I think just before Daniel's question, thanks, Georgie. That's a really interesting point. You mentioned already about, I guess, trying to think about more individual specific rather than team metrics you could use in the second half, because that might help you to get at that. Because my instinct is to think it's the coach, driving a lot of this, based on nothing really, no hard data or anything. But my instinct was, as I say, the coach. And the other thing, kind of just on that, is it'd be fascinating to get an idea of the relationship between player and coach, ideas of what the XG was at halftime versus what Opta thought the XG was at halftime. Because I look at different sources of XG for my team, and I'm often sat there thinking, what on earth is that? Because that doesn't look anything like the game that I just watched. And so I think that's something potentially quite interesting there. You can often hear a coach interviewed or players interviewed after a game, and you think, which game did they watch? Even exclusive of XG, because you think they're talking about as if their team dominated the game when they obviously didn't. So I wonder that what you can kind of do to enter into that space, and hence I think coach fixed effects are one thing, but maybe also if you're able to develop player specific second half metrics as well as team specific ones, that might be really interesting.
Mm-hmm. Thanks. I will try to look it up.
Daniele.
Yeah, I'll echo some of the just the comments that were just made about coaches. I think this is in part the way that you wrote the abstract. You're talking about feedback, so I really was expecting that there would be something about the coach's pep talk at halftime. And I mean, maybe it's just a way like how you presented that you want to emphasize that's not what your paper is about. It's you're talking about this sort of feedback with respect to luck. But other than that, thinking about coaches or including coaches' fixed effects, I wonder if one can measure. I mean, this is based like a purely outcome-based measure. Are there coaches that are particularly good at turning matches around, that they have a really good large fixed effect in the comparison between the final score versus the halftime score? They're really good at getting their teams to improve in their second half. I don't know. These are things that is perhaps worth thinking about. The other comment is I always have a feeling with this this XG is that I actually believe XG. I think it's fairly accurate, even though sometimes it can give things wrong, and in small samples it can give sort of weird results. But I always worry that it's not really accurately capturing what the opponent is doing, right? And those the questions that I also asked in the previous talk, and in the beginning of the talk. And I would have liked to see a specific, so you control for whether the team is winning or losing at halftime, and the score at halftime. I would have liked to you to show some results digging even deeper, like literally just focusing on teams that are winning, teams with high outcome discrepancy versus low outcome discrepancy, teams that are drawing high versus low outcome discrepancy, and the linear specification and the regression may be sort of hiding some things, and I would like to see some just the through scatter plots, what happens like when you just control for teams that are winning or losing, what does it look like? Because I don't have a sort of good explanation for one team dominated possession, had a lot of XG in the first half, but the score is 0-0, right? And the other team, so your prediction is that the team that dominated possession now and created a lot of XG now performs worse in the second half, even if the score is 0-0. That's not necessarily my prior, and if you can show me convincingly that that is the case, which is what your results are saying, then I think that would be that would be useful.
I mean, if a team is having a lot of scoring opportunities, dominating possession and everything, but it's also actually scoring goals, so the OD will not be positive, so will be negative.
Sorry, you're right. It's the opposite. Yeah. Okay, but again,
no, but like
if you can show, it's exactly the opposite of what I said. But if you can show that there is this real, difference, then perhaps I'd be more convinced. I'm partially convinced, but I'd like to be more convinced.
So what, if I understand right, what you will propose is just to have a regression with just winning teams, for instance, to compare them.
Yes.
So I have something like this in the appendix. Sorry, a lot of facts.
That's okay. If you've done it already, then but maybe that should be more prominent.
So, for instance, here we see the effect when the team is winning, just drawing or losing. Of course, some of the, we can still find an effect, and in the paper we comment also on that. Of course, some of the coefficients lose significant, also because some combinations are very rare, like as I showed you before, like OD and halftime state are very correlated. So for instance, like if you're winning, it's more probable that you are you have a positive OD, and so case where the negative OD.
I'm really curious about that drawing at halftime column.
Drawing, so you can see, for instance, here the effect. So here you can see just teams that are drawing at halftime, and we can see the still unexpected goal score positive OD is negative for teams that are drawing halftime, and negative like is improving.
But
like
how? I mean, I know you're controlling for a lot of stuff, but that makes you so obviously that there's one team, the team with the negative OT was creating a lot of chances before halftime, and it continues to create a lot of chances after halftime, right? And the opposite. So maybe that team had more, needed to win for maybe they're playing at home. Maybe it's
they control
you're control. I know you're controlling for all these things, but that there's that's the that's the concern.
I mean, that's the tendency comparing just teams that were playing at home with the same winning probability. So all the variance that explained by this variable is just excluded, and still we can find an effect. And we see, okay, if a team is drawing is a positivity, why it reduces performance? I mean, because that's why I try to convince you, because it's overconfident. Because they say, yeah, we are drawing. So in their head, they are like performing the same. And at the end is due to this overconfidence, they end up conceding more scoring chances compared to the other team.
I'm not sure I'm convinced, but anyway, let's move on.
Yeah.
Thanks, Daniele. Stefan.
Hi, Manuel. Yeah, very interesting. I'm sorry. I apologize. I feel like I've missed something. So you might just want to just. I have to go back and explain something you explained earlier. But what it strikes me is that what's really critical in modern football is context, and that particularly in this era where teams play so many games and you have squad rotations and so forth, that the context of the current game and the next few games is really important. And I didn't see that was controlled for. Maybe you did, so I'm just missing it. So maybe you go over that. But just seems to me that if I'm winning a game and I've got a big match on next week, then I'm certainly going to ease up and take things more easily. Or if I've got if I've got a few weeks off, then I might not do anything about it. I might sort of really continue to try hard and win. So how did you control for context of future games in this?
Yes, thank you for your comment. So the answer is I control for it indirectly. So the assumption is that since I have betting odds, the assumption is betting providers want to correctly derive winning probabilities. And so in doing so, they're not just saying, okay, Real Madrid is better than Malaga, and so yeah, Real Madrid 80% probability, but they probably in their model have a lot of variable, and they also account if Real Madrid in 2 days is playing in Champions League against Manchester United. And so they will reduce winning probability for Manchester United a little bit, for Real Madrid a little bit. So they will account also for this context. So yes, so this is the assumption. And also if Real Madrid has a big injuries for Mbappe, the winning probability will be a little bit lower, so we can account for the context.
Okay, I see. Yeah, that's a lot of weight to put on the betting odds, but at least it makes sense. I guess you can't. Can you get the betting odds at halftime as well? Because that would. I mean, I know. Georgi was saying you could get the halftime scores. I don't know if you could get the betting odds at halftime and see if they've changed, because that might actually help.
No, I don't have odds at halftime yet. I don't know if including this will create some endogeneity problem, right? Because of course, like betting odds at halftime are adjusted like if a team is winning or losing. So betting odds at halftime could be like also the result of outcome discrepancy, so from halftime state. So I think I will commit like endogeneity if I do this. Makes sense?
Yeah, but I mean, if what you're saying is true about accounting, the betting odds are accounting for the schedule, the context of the game, then presumably if you're winning and you've got a tough game next week, your probability, your win probability will not increase by as much as it would if you haven't got a big game next week. So I mean, that would be a pretty strong test of this claim.
Okay, yes. Like you mean to test? Okay, yes. Thank you. I will.
Anyway, interesting. Thank you very much.
Yes. Thank you. Thank you for your comment.
Great. Thanks, Stefan. Probably got time for one more question if anyone has anything they want to ask Manuel. But at least one team's applause. I gave you a team's applause at the end of your talk, Manuel. Just say thank you very much for your talk, Manuel. That was a really, really interesting talk. I think it's a really, really interesting topic, and obviously it's generated a lot of discussion there, and hopefully given you some interesting feedback as you progress with the work. I think the XG factor is a really interesting one, and I mean, I think, yeah, I totally agree with the sentiments, which is that I think XG is accurate. I'm always interested in the variation around, but also the variation between the different providers of XG as well. One of the things I was wondering, I'll just kind of ask you this before we wrap up. I wonder do you think, because obviously when you're watching the live television coverage, you've got XG going on the screen and so on. Do you think that the coaching staff in the dressing room at halftime will reflect on XG, or is the idea that that's kind of implicit in how everything happens in the dressing room at halftime?
So sorry, can you repeat the question again?
I'm basically just kind of thinking a little bit about the mechanism between XG exists, of course, because the stats companies have created it, and it exists in real time because the television companies show it on the screen during matches. But I'm just wondering whether you think, whether it matters whether or not that XG number at halftime is transmitted to the players somehow or other in the dressing room at halftime.
I mean, I think some teams, some analytical team of clubs will do this. Probably not so many, or maybe not at halftime. Yeah, the assumption is that for this paper is not so impacting because still player like kind of, since XG are calculated by events, they are visible and openly available, so to speak, because they know if they missed a penalty or not. So they kind of have an intuition.
Yeah, that makes sense. Yeah, that was all I was going to ask. What I'll do is I've made a few notes during your talk, and I'll email you with them, because as I said, I think it's a really, really interesting paper and a really interesting piece of work. So I'll just wrap up the session. So thank you everyone for attending. Thank you, Manuel. One thing I was going to say at the start and didn't say was that we have a WhatsApp group for the Roses Talks, which kind of sometimes acts as a bit of a sports economics WhatsApp group. If you want to be part of that, send me your phone number. I'm happy to add you to that WhatsApp group. We're going to return next week. Next week, we're going to have Johan Rolek from the University of Loughborough, and he's presenting on the away goal rule in European football, or what used to be the away goal rule in European football, since it's a thing of the past. Thanks once again, Manuel, and wish everybody a great weekend. Thanks, everyone.
Thank you. Thank you for listening to me. Have a great weekend.
Thank you.